Hey folks, so as usual, we're talking about the sovereign data and the storages and all the things. So today I want to talk about the embeddable databases and actually the most relevant things will be about the SQLite. It's applicable to the LeapSQL too actually, but it's mainly about the SQLite. In my previous videos I share with you actually what we could do more. So what kind of embeddable databases it is. So we have a lot of interesting choices, but for our application, we mainly use the SQLite and the story of the database is amazing because the author of the database was working on the battleship and actually he had the problem with the database and the database server and he wrote the database from scratch, but actually he more the specialist in the languages, parsers and all of those things. So SQLite is quite special because the query is compiled to the binary code and the virtual machine actually execute this binary code and unexpectedly it's blazingly fast and quite well written. And another quite interesting story about the SQLite that is practically have no dependency. So the author of the library actually just decided to sit and wrote his own B-trees from scratch. So you don't have any dependencies like CLeap or any other things to make the database working. So and it's make it quite reliable, compact, and really small. And another quite interesting story about the SQLite that they have the process of amalgamation or amalgama. So what the amalgama mean? That all the source code could be glued together to one big C and header file, and it's that's it. So you could just include the amalgamation code to your code and you have the database on board. So amalgamation includes some modules like JSON and all other things, and you could go to the LeapSQL documents and give it a try and check what actually included and so on. So, and as I said, in most cases, it's not even the library, but it's just raw C files and header file that you include to your application code or native code. And sometimes it's create the problems because for example in React Native, if you have multiple native packages for iPhone that use different version of the SQLite, they really could conflict with each other. So they really could pick up something that have quite a different version. And I struggle a lot with this, to be honest, and I still have no good answer on how to solve it. Except that just recompile different libraries, extract the SQLite from there, and all the things that is painful. So, uh, why I really like the SQLite that it's amazingly well tested. So that should be separate video about the tests of the SQLite itself. So if you want to learn a lot about the SQL and how it's work, you could check the SQLite tests for sure. And they really try to be compatible with standards. They try to be compatible with Postgres. For example, the window functions was just copy paste completely from the Postgres specification. And by the way, the LeapSQL have amazingly window functions that could help you to build really complex analytical queries. So give it a try. Be aware about amalgamation, that it's just a big C file. What next? So every embeddable database is just a part of your application, and you need to be aware that it's your application code that eats your resources and it consumes everything that your application have the access to. So here is two side effects. If your application crashes, it's crashed together with the database, and actually SQLite is quite good with the transactions and recovery and all those things, and folks really spend a lot of time to be this crash friendly, but still sometimes these patterns affect not only the database but the application code that work with the data. You should be ready that your operation could be interrupted in the middle, and you should be safe to continue from the point where you just recover. So for sure you could use transactions and all of the things. You could use some step-by-step things that put some extra data to the database to identify where you are and all those things. But most challenge was the embeddable database, that you simply could be killed practically any time. And yeah, so be aware of it. And the next thing, that the SQLite mainly designed for the single user database. You could still use it for the application and do the multi-tenancy and all of the things, but we don't have any kind of permissions. We don't have any kind of permissions. We don't have any kind of row permission or privileges or all other things that actually some other database like Firebird or whatever have. So if you need a permission layer, then you need to build it from scratch yourself, and the database works the best as a single user database. And we could use quite interesting pattern. We could simulate the multi-tenancy with the multiple database, so one database per user. And actually the SQLite have quite interesting property of attached databases. You could attach some general database with the application state, another database with the user specific data, and maybe another database with some kind of overall application configuration and so on. So you really could slice your data to the different domains and different schemas that will be stored in a different files. And actually it's quite interesting pattern. Don't be scared to use it. Actually it's unlock a lot of things, because yet another thing to remember, that SQLite designed for the single writer. So that's quite challenging to have the multiple simultaneous writers to the SQLite file. So you need to be aware for the React Native and mobile application with the Node.js on board is not a big deal, because it's usually single threaded, so you will not have the cases where you have the parallel threads that try to write to the database. But just be aware of it, use transactions carefully, and you could play with the BC time and all of the things. So if you really need to do the parallel writes, maybe the first of all switch to the vol mode journal, and then it's a lot of other hacks that actually allow to do something around it. But in general it's a single writer, it's a single user database, no permissions and so on. So the next thing is quite important to understand, because a lot of people doesn't understand it when they start working with the SQLite, that is flexibly typed. So flexibly typed is doesn't mean weak typed. Don't be wrong. So the flexibly typed, it means that by default you create a table that use the types mainly for some suggestions and types affinity, but you could store any kind of value inside the cell, because it's not about the rows, it's not about the tables. The types always decides on the level of the cell. And another thing that usually in the different databases you need to say precisely what kind of size every field have, because you need to have the fixed size of rows. But it's not the story with the SQLite. SQLite just store every cell with the amount of memory required for this particular cell. So the rows could have actually the different size, and you don't need be so picky to say that it's varchar 36 or whatever, because SQLite doesn't care. If it's text, it will be stored as a text. If you say the type, it's more about suggestions, so the SQLite will try to follow your suggestion, and if it will see the number, it will try to store it as a number, is if you say that it's a number, and so on. If you don't like this behavior because it's quite error prone, you could use the strict tables, but the strict tables will require a bit of more work, so you should be careful. Yet another interesting thing about the types, that's just a couple of types in the SQLite. So it's the text that represent the strings, it's the integer, it's a type real that actually in practice is just a float, and blob, and that's it, nothing else, and to be honest, and everybody else is just the LDSs on top of these types, and yeah, that's it. So what else to say, that you could ask what about the date type. So the date type actually doesn't exist in SQLite, but they have the powerful functions that work with the dates, and these powerful functions actually understand the ISO dates, they understand the timestamp epochs, and they understand some magical Julian days. It's the amount of days since some Julian whatever event in a history. So I don't remember it by heart. So you could check the documentation. So the SQLite work with dates quite well, but you need to be aware that yeah, it's not such type like a date. Then yet another discovery for me. So that date.now from the JavaScript and UniEpoch from the SQLite, they differ from practically the thousand of the magnitude. So you need to be careful if you store the timestamps from some Node.js or JavaScript applications. You probably need to take care that this difference will exist. But SQLite work quite well with dates, even if it doesn't have the date type. The same for bools. You could use the 0 or 1. The later version of the SQLite understand true or false, but they just translate it to the 0 or 1. So that's it. So yeah, you have some ephemeral bools, but it's just the numbers. So maybe you could precisely use the numbers. But the most important is this weekly or flexible type schemas. So it's mean that you could store the dirty data in a database. It's mean that you could use some entity value attribute, and even in a strict mode, you have any type that allows you to store practically any kind of value, whatever they want. So it's a feature. It's not a bug. You need to remember that the foreign keys actually are optional. So, and by default, they are switched off. So be careful. If you need the referral consistency, then switch it on. And yet another thing that is quite important, that SQLite, even the amalgamed one, support JSON quite well. You could even index some JSON extracted fields and all other things, but you need to be aware that it's slow. It's much slower than the regular columns. It's much slower than the regular tables. So you just need to be careful that if you go this documentish like way with the SQLite, it could be slower just. And if you want to be more compact in a data size, then maybe you could give it right to the JSONB that already supported in SQLite quite well. So, that's it that I was keen to share with you. It's a lot of insights and a lot of quite interesting things in SQLite, but the flexible types actually, and the single user multi-tenancy is what I was keen to highlight in my video. So follow me on my YouTube, read my Medium blog channel, and let's stay connected. See you next